Hello everyone, welcome to my channel. In this video, I will explain about Bayesian network. So first let us see the definition. A Bayesian network is a probabilistic graphical model that represents conditional dependencies among random variables using directed acyclic graph and conditional probability tables. So what is the meaning of this Bayesian network? Remember all of you, it is a probabilistic graphical model. Okay, so what is the meaning of Bayesian network? It is a probabilistic graphical model that represents conditional dependencies among random variables. So Bayesian network represents the conditional dependencies among the random variables. So it is going to represent the conditional dependencies between the random variables using directed acyclic graph and conditional probability tables. So this is called as what we say Bayesian network. So please remember all of you, directed acyclic graph in short we called as DAG, conditional probability table in short we called as CPT, and probability graphical model in short we called as PGM. Now let us see what is this DAG and what is this conditional probability table. So you observe, a DAG is a directed acyclic graph used in Bayesian networks where directed acyclic. So what does it mean by directed? There is something called as arrows which show the direction. This is something like a cause and effect. Okay, and second one is the acyclic. So what is the meaning of acyclic? Acyclic means there is a no loops. So this is called as what we say acyclic graph. Okay, now what is the meaning of conditional probability table? So please remember all of you, a conditional probability table which specifies the probability of a variable, a given parent variables in a Bayesian network. So it specifies the probability of a variable. So it specifies the probability of a variable in its parents variables in a Bayesian network. Okay, so in simple words, how likely a node is depending on its causes. So simply how we can explain this conditional probability, how the child is depending on its parents. Okay, so now you see a Bayesian network graph is made up of two things. So first one is called as nodes and second one is called as arcs. So here arcs are nothing but directed links. So this is a graph, Bayesian network graph, which consists of nodes and arcs. In this diagram, A, B, C, D are called as nodes, and here arcs are nothing but, you observe, A to B is one arc, B to C and one more arc, D to C one more arc, and A to D, this is the another arc. So each node represents or corresponds to random variables. Yes, so here remember all of you, A is a random variable, B is a random variable, C is a random variable, D is a random variable, and it can be continuous or discrete. Okay, so arcs are directed arrows represents the causal relationship or conditional probabilities between the random variables. So this directed arrows represents the relationship or conditional probability between the random variables. So these directed links are arrows connected to the pair of nodes in the graph. So you observe, if there is a directed link A to B, okay, so you see on the screen in the graph there is a line between A to B. So this is the A to B. What is the meaning of this A to B? Node A influences node B. So this node A influences node B. So when the arrow towards the B, so from A to B, which indicates that node A is influences node B. So A is also called as parent and B is also called as a children. Okay. Now if you observe, if there is no direct link between two nodes, they are considered as independent. Okay, so if you see, if there is a no direct link between two nodes, so there is no direct link between A to C. You observe, there is a link between A to D, but there is no direct connection between A to C. Hence, A and C are called as independent. Now you observe here in the above diagram, A, B, C, D are called as random variables, represented by the nodes of the network graph. If you are considering node B, which is connected to node A by a directed arrow, so this is called as directed arrow. Then node A is called as parent of node B. Yes, node A is called as parent of node B, and node C is independent of A because there is no more connection between A and C. Okay, now let us see what are the uses of this Bayesian networks. So important point. So first important use is we are using in medical diagnosis field. So Bayesian networks we are using inside the medical diagnosis, and second one is the optimized web search, and third one is the spam filtering, fourth one is the Gini regulatory networks, and last one is the data analysis prediction. Okay, now the main objective of this Bayesian network is to understand and model the causal relationship between the variables. So it is going to show the causal relationship between the variables. They capture here cause and effect relationships, so as well as helps in reasoning and inference using the probabilities. So example, you observe cause and effect. So this is something like a symptoms. So when you say the symptoms, we can predict the disease. So this is something like a relationship between symptoms and disease relationship is modeled. When new patient arrives, the network calculates the probability of diseases, and it helps in making the accurate predictions. So this is called as what we say a Bayesian network. Okay, now you observe on the screen, it is a mathematical definition of Bayesian networks, one of the most important formula. Kindly note down all of you. So this is a mathematical formula of Bayesian networks. So you observe P of x1, x2, so on xn is equal to pi of I is equal to 1 to n. So P of xi by parents of xi. So in this, if you observe this P of x1, x2, so on xn, so this is called as joint probability distribution. So this is called as joint probability distribution. But if you observe this symbol, this is equal to pi of I is equal to 1 to n. So what is going to be happen? This is nothing but a multiplication. Okay, so in the multiplication, what is going to be happen? It means we are going to multiply all probabilities from I is equal to 1 to n. So instead of writing long multiplication, we use this symbol. So you observe here, instead of writing long multiplication, this is something like, let us say I is equal to 10. I is equal to 1 into 2 into 3 into so on up to 10. But instead of writing long multiplication, this is a mathematical symbol to represent the multiplication values. So now we have one more thing which is called as a individual variable. So this is x of I is called as here, this x of I is called as individual variable. Now what is the meaning of this P of xi by parents of xi? So it is nothing but it is a conditional probability. So probability of a variable given its parents. So this is nothing but probability of a variable given its parents. So it comes from the CPT, which is called as conditional probability table. So the joint probability of all variables in a Bayesian network is computed as product of conditional probabilities of each variable in it given its parents. Okay, so let us understand more clearly with this example. So you need to write this example in the examination point of view. Bayesian network example. So here there is some story is there. Harry installs burglar alarm. So Harry installs burglar alarm system in his house to detect burglary. So what is the purpose of this burglary alarm? It is used to identify the theft. when the theft is going on, it will give some alarm. Okay, the alarm works well for detecting burglary. So always it will identify the any theft is going on, but it may also ring due to minor earthquakes. So sometimes it may happen when earthquake coming, it may give some sounds. Okay, so then what is going to be happened? There is a confusion where this sound belongs to burglary or else others. So Harry has two neighbors. So first person is David and second person is Sophia. So the person name is called as Harry. He is having two neighbors, David and Sophia, who inform him when they hear algorithm. Okay, so David and Sophia will inform to Harry when they hear alarm. So when they hear alarm, they will identify, they will inform to the Mr. Harry. So here David and Sophia are neighbors of Harry. Now what is the conditional here? The condition is David is always calls when he hear the alarm, but sometimes calls even he mistake other sounds. So remember what is the main goal of this David? David should inform to this person is called as hungry. But if you see, David always calls when he hears alarm. Okay, but when David hears this alarm, sometimes he calls when even he mistake other sounds. When he listen other sounds also, it is called as false alarm. So the false information will get sent to the hungry. Okay, so now Harry, Sophia sometimes misses the alarm because she listens to the loud music. So sometimes Sophia misses the alarm because of she listens to the loud music. So in short, what is going to be happened in this story? So the person name is Harry. He installed burglar alarm. So what is the purpose of this burglar alarm? It is used to identify the theft in the Harry house. Okay, so there are two neighbor persons are there for this Harry. So these their names are, you can observe on the screen. So their names are, first person is David and second person is the Sophia. So the responsibility of this David and Sophia is when alarm makes a sound, they call to Harry. But unfortunately, sometimes it may happen, what is going to be happen? When David may hear algorithm, sometimes when the mistake other sounds. So when theft is not going on, something like when earthquake comes, so it will also give some sounds. So by the way the alarm is going to play, then David is going to inform to Harry, it is false alarm. And Sophia sometimes misses the alarm because she listens to loud music. Okay, so sometimes what is going to be happen? This Sophia is not going to listen the alarm because she may get loud music from other places. Now what is the problem statement over here? So the problem statement here, so we can observe one of the most important point here. So what is the meaning of this problem statement? We are going to find the probability that alarm has sounded. Okay, so alarm should play and there is no burglary, means there is no theft is going on, and there is no earthquake. So no earthquake is there, no burglary is there. Both David and Sophia have called Harry. Okay, so what is the goal of this David and Sophia? They inform to Harry when the theft is going on. So this is the called as probability we are going to find now. So list of all events occurring in this network. So what is the first event? That is burglary. This is nothing but thefting. Second one is the earthquake. So when the earthquake sounds, sometimes David informed to Harry. Alarm is played in Harry's home. So next one is the David calls and Sophia calls. So remember all of you, these are called as list of events in this network. So let us write in sequence. So the first one is, here you observe, first one is the probability of D of S of, so you observe, so first one is the D nothing but David calls, S nothing but Sophia calls, A nothing but A is the alarm, B is a burglary, and E is the earthquake. So remember all of you, we write some conditions. So what is the first condition? D depends on A. Can we say David calls depends on the alarm? Yes. And second one is the Sophia calls depends on the alarm? Yes. But when you see this alarm depends on burglary. Burglary means thefting, and E nothing but earthquake. Yes. So that's why we have written one more dependency. So remember, in this burglary and earthquake, these are no parents. These are no parents. So these are not having any parent values, because burglary is a most important issue. It is nothing but it is going to identify the theft. Okay. So even earthquake is also parent nodes. These are no having parent nodes. So indirectly we can say these B and D are not having parents. So these two are act as a parents. Okay. Now you see, if I write this P tends to E, D, S, A, E. So these are called as, we write all the values. So what is the probability of this one? So simply we are going to write this one, P of D by A. Yes, D depends on A. P of S by A. S depends on A. So P of A by B comma E. So this is B or E. That's why we have written B comma E. So this is P of B. So if you observe here, B by E. So this is P of B into P of E. So this is called as a probability of D, S, A, B, E. Okay. Now in order to understand better way, I will have one more example on the screen. One of the most important diagram for this Bayesian network. So in this diagram, we contain completely 5 random variables are there. First random variable is burglary. Second random variable is earthquake, and third random variable is alarm. Fourth random variable is Sophia, and last one is the David. So Sophia and David. If you observe here, we are going to find out the conditional probability table for each and every random variable. Okay, so we have some values regarding burglary, earthquake, alarm, and so on. When it comes to this burglary B, so this is nothing but the theft. Okay, so burglary B represents the, here what is going to be happened? Burglary B represents whether burglary has occurred, means the theft is occurred or not. So remember, this variable does not depend on any other variables. You observe here, alarm depends on burglary and earthquake, but it does not depends on any other variables. Hence this is called as root node. Okay, in this when B is equal to true, means the burglary is equal to 2, which indicates that, so we are going to have this is equal to 0.002, indicating that burglary is rare event. Okay, but if you see when it is false, so this is equal to, when B is equal to false, the probability is 0.998. This means burglary usually here, which is called as, it does not occur. Okay, so thus the burglary is a rare independent event. Okay, so this is called as a burglary. Second one is the earthquake. So earthquake, remember, burglary can be represented with B and earthquake can be represented with capital E. So the variable earthquake is represents whether earthquake occurs. Okay, so thus the variable not dependent on any other variables. So hence we can say this is called as a root node. So if you observe here, when true, this is equal to 0.001. So which indicates that when E is equal to true, the probability is 0.001, showing that earthquakes are very rare. Okay. So when it is false, what is going to be happen? The probability is 0.999, meaning that earthquakes are rarely happen. Please remember, all of you, these values are not fixed. You may have some confusion, something like how we receive all these values. These values are not fixed. So when I say burglary true value is 0.002, just we assume this value. Please remember, all of you, don't make confusion. So you may get other values in other textbooks. These values are not permanent. Okay. So I assume the value of burglary true is 0.002. The value of earthquake true is 0.001. But you should remember one thing. When you have true, false condition is 1 minus true, that is 1 minus 002, that is equal to 0.998. So if you take here 0.3, you must subtract 1 minus 0.003. So the final answer will write here. So in this, the true value is 0.001. So we can subtract 1 minus 001 with this value. Okay. So finally we get this value. So this is about the burglary and earthquake. So remember only one thing. True value is 0.002. False value is 1 minus 0.002. So in this, the false value is 0.001. So this is called as burglary and earthquake. So third one, what we have here, alarm. Okay. So what it shows, alarm. So alarm represents whether alarm rings. So this is the most important criteria about this diagram. So whether it shows that the alarm rings or not. So this variable depends on both burglary as well as earthquake. So when some theft is going on, it is going to play the alarm. When earthquake happens, in this situation also, it is going to play the alarm. Okay. So now this is the conditional probability table. So if you observe here, burglary, so this is about the burglary and this is about the earthquake. So when both are true, burglary and earthquake are true, the alarm rings with the probability 0.94. So very high probability. Okay. Because when theft is going on, when earthquake may come, what is going to be happen? Due to different sounds, it is going to identify the theft. So the percentage is called as 0.94. So this is high probability 0.94. But if you observe true false, this is nothing but what is going to be happen when the true false is there. Here burglar is true, but in this earthquake is false. Okay. So only one component is true. So that is equal to burglary. So then what is going to be happen? The theft is going on. When the theft is going on, it identifies 0.95. Probability is 0.95. Okay. This is a burglary is false, but only earthquake is going on. So it will have the probability is 0.69. So when both are false, means no sounds, something like no theft is going on, no earthquake. So we may get 0.001 chance to get the sound. So this is called as a alarm. But if you observe, we may also check the false condition. Okay. So when it is false, when alarm is going to play this one, but when it is going to have false, remember, just you subtract 1 minus 0.94, this is 0.96, which indicates that when burglary is true as well as earthquake is also true. So some theft is going on, even some earthquake is happened. then what is going to be happen? The alarm is not going to play only 0.06 probability. So similarly, we can find when burglary is true, earthquake is false. We can check this one. When burglary is false and earthquake is true, so this is equal to 0.31. How we receive this 0.31? Just you minus 1 minus this one, 0.69. So what is the value of this one? This is equal to 0.31. So 1 minus 0.001. So this is equal to 0.999. So this is called as conditional probability table. Okay. So this is a way to construct this conditional probability table for alarm. Okay. So we'll check next one is the David calls. So David calls represents whether a David calls after hearing the algorithm. Okay. So when he listen a sound from alarm, okay, so the variable D represents the David makes a call to Harry after hearing the alarm. This variable depends on only alarm A. So please remember, David depends on only alarm A, but he not depends on burglary and earthquake. Okay. So now if you observe the probability, when the alarm is true, yes, alarm is make a sound. When D is equal to T, this is nothing but here what is going to be happen? When alarm is true, the probability of David is 0.91. Okay, so the probability is 0.91. So when he listen alarm, he informed to his friend. Okay, now what is the chance of getting false? Even though the alarm is going on, okay, true, but unfortunately we may have some consequences or negative things also. So the thing could be a false information, very minor, 0.09. So remember, just to subtract 1 minus 0.91. So 1 minus 0.91, this is equal to 0.09. So when you see false information, this is equal to 0.05. So which is equal to 1 minus 0.05. This is equal to 0.0. This is 0.95. So when it comes to Sophia, so again remember, this variable Sophia is depends on the alarm. Okay. So what is going to be happen? When alarm is true, yes, when the alarm is true, this point. Okay. So this when the alarm is true, and what is going to be happen? The probability that Sophia calls 0.95. Okay. Now when the alarm is true, how much probability it does not going to have? That is 0.75. So please remember, all of you, one of the most important point, whatever the values you have taken for true, when you go for false, so when here the true value is 0.15, but in this the false value could be 0.25. So whatever the value you have taken, this one, just 1 minus 0.75, this is equal to 0.25. 1 minus 0.02, that is equal to 0.98. So this is called as the conditional probability table. Now we have the formula. We are going to find out the joint distribution. So how to find out this joint distribution? So you can observe on the screen, the formula is there. So what is the formula over here? The formula is this is called as important formula to find out the joint distribution. Okay, if you observe here, you can see in this P of S D A negation B negation E. So what is this S D A? You observe, S is a Sophia calls, D is a David calls, A is a alarm, okay, and burglary, earthquake. So we are going to take the negations of B and E. Okay, so here you observe the alarm has sounded, but they mentioned in the above we have taken no burglary, no theft, as well as no earthquake. So when even though no earthquake or no theft, we are going to find the probability of this David and Sophia will call to Mr. Harry. Okay, so that's why we have taken three variables as SDA and we take a negation of this B and E. So indirectly we are going to remove these two from this 3. Okay, so now what is the formula regarding this one? P of S by A into P of D by A into P of A or negation B and so on. Now if you observe here what we have to substitute over here. So first, what is the first value? S by A. Okay, so if you see here, what is the value of this S by A? So S nothing but here Sophia. Okay, this is Sophia. S by A nothing but it is A nothing but alarm. So this value is called as S by A because this is the true value of Sophia. That's why we have taken 0.75. Next one, D by A. So this is called as D. This is called as A. Okay. So when the alarm is true, the value is 0.91. This is called as this value. So next one, what we have? P of A. So remember, when you say yes, we find out the variable S. When we find the D, we go for David. But when we find the starting value is A, we should go to alarm. So we need to negative values of B and E. So burglary and earthquake must be false. So burglary and earthquake must be false. Okay. Now, but alarm should be true. Yes. So in this alarm is true, but these are false. The final answer is 0.001. So this is called as 0.001. Next, negation B, negation E. So what is the value of negation B? Yes, negation B nothing but this and negation E nothing but this one. So 0.998, 0.999. So negation means false value. So 0.998, 0.99. So this is the final answer of this joint distribution. So this is all about the Bayesian networks, one of the most important question in the examination point of view. So this is the Bayesian networks. So thank you for watching this video. Please subscribe my channel. If at all you have any doubts, you can ask me in the comment section. Thank you one and all.